Hello and welcome to another tutorial. So this time we are going to be making a couple of additions to the first-person controller. So what we're going to be doing is starting to build out some extensions essentially for it. Because what I want to do over time is build it up so that we have additional sort of modular pieces that we can add into it. And the focus for today is going to be setting up so that we have a pickup system, and we'll also be making a couple of little sort of improvements there as well along the way. So we'll dive right on in. And what I want to do with the pickup sort of setup is I'm going to, with our character motor, I'm going to actually create a folder here above that I'm going to call extensions. So we'll call this extensions. And actually I might put it in the main character motor folder. So, okay, these extensions, at this stage I don't have a good feel for whether there'd be a lot of common base stuff. So I'm not going to add in any common base stuff currently. Then this is something where when you're laying out stuff, you need to look at the possible use cases that you have to work out how you want to structure things. So in this case, I do want the pickup stuff to be something that's separate from the core character motor. And there might be other things that I do as well that could be extensions. So it could be things like inventory and stuff like that. But there's not a lot of similarity or overlap between them. They exist on the character, on the player, and it's useful for them to exist alongside it. But there's not a lot of common interfaces there. So at this stage, I don't have a good use case for a base class. So I wouldn't actually set up a base one. What I would actually do is, firstly, I will create a folder for the scripts for this, and then I'm going to set up one where I'll call this pickup scanner. So with the way the pickups I want them to work is I want to support two types, because I think it's important to support a couple of different options here. So one type, we will move over it and it will be acquired. The other type, we look at it and we hit a key to pick it up. So I want to support both types and support both types with the same system. So I'm going to create another script here that I will just call pickup. So the idea is pickup will be on the thing that we collect, and the pickup scanner will sit on the player. So our player, which we've already got quite a bit of stuff on the player, so I'm just going to collapse a lot of those things. And it has gone, and this is in part because of how it works with the require component. It's added in another gravity tracker there. So what I'm going to do is bring on the pickup scanner, and I'm actually going to go and make, before we dive into pickups, a little bit of an improvement, a little bit of an update for the character motor. I want to get rid of the require component that it will have for the gravity tracker. And what I'm going to do is I'm going to make it that it can work even if there's no gravity tracker. And kind of the easiest way for me to find the bits I need to fix is to comment out the gravity tracker. So with that commented out, I'll now get a bunch of errors. So I can see the things that it's highlighting. So ones where we've got just a direct up vector, ones where we've got a direct down, and most of those are ones where it's got just up and down vectors, which is good. And we can go and check and see how those are calculated. So if we go to gravity tracker, we can see that these up and down ones, so up and down are actually the normalized versions. The force gets directly applied, so that's something where if we don't have a gravity tracker, we would need to be applying that in the character motor, which is fine. So what I would set up then is in our character motor, a couple of little helpers here. So I would have public vector 3 up vector, which if local gravity is not equal to null, then that ends up being local gravity dot up. Otherwise, it's vector 3 up. And a similar thing for the down vector, where we just provide those. And then each of these ones through here, I would come through and update them. So this would go to up vector, and we just go through and we fix all of these. That way then we'll remove that dependency on the gravity tracker having to be there, and it can work with or without it, which is good. It means that we won't necessarily always need things like the gravity tracking, so it makes that a little bit easier for us. So we have down vector. So just fix up each of these different ones. And a lot of them are going to be up vector because that's actually one of the main things that we do end up using. Whereas we do have a couple of ones that are down vector, but the majority are going to be up. And this just gets this cleaned up before we start making the further modifications. So those are all up to date. Have down vector. So that's everything fixed up with those. So now the only errors that we've got are ones where it's trying to refer to local gravity, which is fine. We can fix that. And then the final bit we would do is in our fixed update, we would just check and see as one of the first things, well, if local gravity is null, then similar to what the gravity tracker does here, where we apply that acceleration, we can go and ask, okay, physics system, what is the gravity vector? And that's actually something where you can customize that. So if we go to our project settings, we can actually go to the physics system, and you can see here, here's what the gravity vector is. So that's something where if you did need to customize that globally, you could use that approach for fixing that up as well. So that's good. We've got our character motor changed around, so that's going to work a lot better. So we won't find that it goes and adds in those extra things as often. So now the pickup scanner. So pickup scanner needs to have a couple of ways of working with things. It needs to be able to have things that we react to based upon collision with them, and it also needs to have things that we look at. So it's got to be scanning the environment for things, and what we want to do is, generally for something like this, I'm going to first set up an empty game object, which I'm going to bring over here. I'm just going to adjust its height. Now, if we go for a height of 0, then it's going to place it squarely on the ground there. So this is going to be our pickup. So what I would generally recommend for structuring stuff like this is we create an empty object under that, which is the mesh root. That way we can have the visible mesh for the object actually sort of separated. We could animate it separately from the actual pickup itself. On the pickup is where I would add a collider. And I think something like a sphere collider is going to be most appropriate. And we'll set that to be a trigger. Now what I would also do is I would set up another layer for this. Now, while we might not necessarily be doing anything where we're making use of the fact that there's another layer, something like this where it's got different functionality, we may want to raycast differently against it, I would recommend setting up another layer for it. Just means that you've got that done from the start, and it's very easy then later on if you need to make those changes. So, okay, we've got that. This will get the pickup script on it. So that goes onto the parent object. And that's going to need to store a little bit of information because this also is going to potentially need to show some little bits of UI. So what I'm going to do is we've got two different ways of how we could approach this UI. We could have UI per pickup, where it's anchored in the world. I tend to think that looks better. Or you could have UI that appears on the HUD that it talks to. I'm going to do this for a little bit of UI that appears in the world, because I think that's a better option for it. So prompt UI. So this, to make it world space 1, we change the render mode to world space. And what I would recommend for the sizing for this, so something that I always recommend with world space UI, is width and height, make them a logical number of pixels. So make it a logical pixel size and then adjust the scale here to bring it down to the size that you need. So to get the sizing right, I will add in a panel. And I can see initially that is gigantic. So resist the temptation to be like, I'm going to make these really, really small values here. You can, but then it makes it a lot harder to actually design and plan the UI because you're not working in something that's a more familiar size like pixels. You end up doing things where it's like, okay, I'm going to move this 1/1000th of a pixel, or worse, you end up things with like, I'm going to move this 17.35 thousandths of a unit across, and it becomes a mess. So what I would do is I'm going to set this so the scales are linked. Generally want to start probably around 1/100th and then probably reduce a bit further at that point. So that's decent. That's getting to about the right size. This is probably a size where I could then shrink that width and height a bit because I've reduced the rest of it to a much more reasonable size, and I think we can shrink the height a bit further again. Offset that a bit. So that looks good. It generally depends on the color palette of your game, what you would want the background of this to be tinted. I generally will go for tinting it to be a darker background. It's often going to help it stand out better, but it depends on the color palette of your game. So you might want to go for a lighter one if you've got a very dark color palette to the game. So then this is just going to have a little bit of text in this. And there are two bits of text that we might sort of want to show in this. There could be a little bit of a description, and there would also kind of be an instruction. So the description, we're going to bring that and anchor that at the top. So we don't want any further sort of spacing, and height-wise, we're going to give it probably, so we've set a height of 160. So I think we give this about probably 120 of that height, maybe even maybe just 110. Then the instruction, we anchor that down the bottom this time. And its height can stay at the 50 there. And I think in both cases, we would center them like that. So the instruction would end up being something like press E to pick up. So there we go, we have our instruction. So that's good. Now what I would then do is we need our pickup to actually have some links to those things. So we're going to bring in Text Mesh Pro. I'm also then going to here, we'll set up. So we have our Text Mesh Pro UGUI, and one is going to be the description text. The other is going to be our instruction text. In case we want to update that, we might. And then I need a couple of other things. I want the transform for the canvas root or the UI root object, just so we can angle that UI as we need to. And then I will also, because it would be handy, canvas group, UI group. That will allow us, having a canvas group on there, will allow us to actually sort of fade it out if we need to, which can be really handy. So our pickup, we can link each of these different things. We have our description, our instruction, our panel. We give that a canvas group, and we'll link that up as well. That just makes it, with the canvas group, you can see here, we can adjust that alpha really easily, so it makes it great if you need to fade that. The prompt UI, we can test and see, we can rotate that so that pivots around the center point, which is good because we'll want that to be able to face the player. And then I'm going to turn that off. So we don't need it on, but it's just good to have that visible there. So this is pretty much going to be the majority of our base for the pickup. I want to also have the transform for the mesh root object, because this will allow us to, if we need to, animate the mesh. So we'll link up the mesh root. The other thing I will do is I'll actually offset the collider for this. So I'm going to bring that up so that it's sitting above the ground fully. So that looks good. We've got our pickup that we can place anywhere on the ground. We've got our mesh root. So we're in a good spot with that. And the player has their pickup scanner. The other thing I would add into this is making sure that, let's test this with, I'm going to put in a default object, which will put in a cube that we will turn off its collider. Actually, I'll leave the collider there, but I will turn it off for now. And what I'm going to do is just move this. I want to reduce the size of it a bit. So there we go. So, okay, our pickups, it might be good to be able to have them bounce and move around. So I'm going to add in that little bit of functionality first. So general, and then we'll have movement. So then we'll have a float for rotation rate, rotation speed. We do this in degrees per second. So I think a fairly slow rate as a default, I think, is reasonable. I will also just make sure all of these are protected. Private, I think, we might inherit from this, so I think useful to have it not be private. I will also have a bounce amplitude, so how much it sort of bobs up and down, and I might make that 0.25. We don't want it to bounce a huge amount. And then we want the bounce period, so how long it takes to complete a particular bounce. So again, something like if that, I want it to go fairly slowly, so I think probably something like 4 seconds as a starting point. So if we're going to be bouncing something, we need to keep track of the mesh root, stuff like that. I'm also going to, just because it might be useful, have a bounce offset, so we can offset something above the ground a fixed amount. So it can bounce, but we can also offset that. Could be quite handy. So what I would be doing is to update the progress of this. Well, rotation speed is pretty easy. We would do mesh root object, rotate, and we can give it, we could tell it rotate around. What I would do is rotate, and we can, with this, we have a few different versions. I would use the version where we just provide the specific Euler angles, because we do rotation speed by time delta time. So that's quite an easy one. Okay, so I've set this up so it'll be rotating. So what we then want to do is we want to make it bounce. So I can work out my bounce progress, and kind of an easy way of being able to do this is I can go time.time percent, which is the modulus operator. It gets the remainder of doing a division. If I do the modulus with bounce period and then divide that by bounce period, what that's going to do is it's going to say, okay, take the time.time, work out how many times would our bounce period fit into it and how many actual full multiples of that would fit into it, and then throw that away and get me the chunk of time that's left over. So if I was at 0.1 seconds, it would give me 0.1. If I was anywhere up to our bounce period, it would just give me back that current time value. But if I was at, say, 4.2 seconds, so 0.2 over our bounce period, I'd get back 0.2, which is really handy. So doing this gives me back a value for the time that's between 0 and 1. What I can then do is I can then go and say, okay, well, height offset is my bounce offset plus the bounce amplitude multiplied. Now I could use sine or cosine. It's not going to make actually a meaningful difference in this case, especially after the game's been running for a bit. So I would usually just go with sine. Now sine goes up, then down, goes below 0, and then back up. And that full cycle repeats, and that takes 2 pi radians. So what I can do is bounce progress by math f pi by 2. That's going to mean that as that bounce progress goes up, it's going to capture a full cycle. Then I can say my mesh root object, its local position is vector 3 up by height offset. So that's just going to make sure that's moving correctly. So then we'll take a look. This should, so it runs. So that's good. We've got our pickup bouncing nicely. We can see how it looks. So fairly classic sort of movement there for a pickup. So, okay, good so far. We want to detect that we've actually walked into that. So this is where the pickup scanner comes in. So one of the things we can do is we can have void on trigger enter. And then what we want to check is this thing a pickup? So pickup logic. We can go, well, f other try get component. And what we do is we try and get pickup out pickup logic. So if that was successful, then we'll have been able to actually grab it, which is good. I can actually get rid of all of these other things. Don't need any of them. So the pickup, we need to know whether it is a sort of instant pickup. So this is where what I would do is I might actually set this up where we use the process where we can apply the property to the backing field. And we'll have a public bool is instant. And that will be a protected set. And we'll default that to false, but I'll manually set that to true. Now, this is something where header in a case like this can get confused. Now, it may work okay to let us do this. And then what I can do is, okay, well, f pickup logic is instant. And we probably want to ask it, can it be picked up? Because there might be a reason we can't pick it up at the moment. So if that's the case and can pick up is true, then what I would do is pickup logic dot pickup. So I'm going to set up a couple of things here where we will have protected virtual bool can pick up, because we want to make sure we have those interfaces ready to go, which by default I will set that to be true. And then we'll have a protected virtual void pickup, because again, that might be something we want to have options for. I can actually bring my header one back up here, because what I'm going to be able to do then is have a serialize field of a protected bool despawn on pickup, which will default to true. And here, well, we need to change that function to on perform pickup. That actually had to be public. So we have perform pickup, which that's going to check, okay, well, if we despawn on pickup, then we destroy our game object. I also want to be able to send an event that it was picked up. So we're going to bring in Unity Engine events. And what we will have here is events, Unity event, and we'll make it that it passes through the pickup on picked up, because that would be potentially useful for it to send that, and we'll send that before it actually does the destruction. So that's good. We should have something where that's hopefully now fixed up. That should be able to see. That one has to be public as well. So what we want to do then is check, okay, does this work? We should be able to wander over to this, and we'll set it to instant, and it will destroy. So we've got the player here, and there's our pickup. So that's good. That worked. We can have that working nicely, which is great. So, okay, good so far. We can do that checking, but we might have ones where it's actually one that we have to look at it. So this is something where the pickup scanner, it's going to need some options here. It's going to need a float for the detection range. And this is going to be probably something like 2, maybe 3, or 2.5. We don't want it to be too large a range. We want to have a serialized field for the layer mask, detection mask, and I'm going to default that to all layers that it will raycast through. So, okay, good so far. And we might want to be able to override the camera. Don't have to, but it could be useful to be able to potentially override the camera that it's looking from. I'm also going to make it that it has a detection interval. So essentially how rapidly it's sort of scanning. And we might make that 0.1. Don't want that to be too large a value. Otherwise, that's going to potentially be a bit of an issue. So, okay, that's good. What I would do is next detection time. starts at 0. And here, if next detection time is less than or equal to 0, then we're going to reset it. Otherwise, we update the interval. Run pickup check is what we'll then do here. So good to have this interval because we might not want it to be scanning all of the time, and it is a check that's doing raycasts. It is a bit more intensive. So, okay, we can now set up our raycast. So what I would do is first we need the particular camera that we're working from. So working camera, well, if override camera is not null, then we use override camera, otherwise we use the main one. Then, so I'm going to have a raycast hit result, and I want to do something where what I've got, take a look at the different options. I need to provide an origin and a direction, easy enough. That would be working camera transform dot position and working camera transform forward. We could just go with the version that's straight out with that hit result, but if we look at the different options, I want to be able to provide this distance and a layer mask and let it interact with triggers. So I actually want to provide these 3 other bits of info. So the order they need to come in is distance, layer mask, and then the trigger interaction. So I would provide detection range, detection mask, and I want to have it interact with triggers. By default it won't for a raycast, and I actually really want it to in this case. So check if we can hit anything. And then what I would need to do is check what it hit if that has a pickup on it. So very similar to what we had down here. Although the logic here will be fairly similar, ones that we're looking at work a little bit differently. So I do actually want to keep the logic separate for now, because what I will do is it will try and get this from hit result dot collider. And then what it would do is F the pickup logic. So we need to think about this. The ones where we look at it, this is one where it needs to have a prompt, so it's not an instant thing. And I might actually rename isInstant to pick up on contact. I think is actually a better term. So if it is not a pick up on contact thing, then I want to be able to record that I'm looking at it. So I want to be able to go, hey, pickup logic on start or continue looking at. Except be nice to distinguish those. So I'm going to actually keep track here of pickup logic. So our current pickup target. So I want to check here. Okay, well, if pickup logic is not equal to our current pickup target. So the pickup target has changed. So I've started looking at something different. So what I would do is I would go, okay, well, pickup logic on start looking at. So if they're different, we do that. Then I want to check, do I already have a current pickup target? Because if I do, then I would go current pickup target on stop looking at, because we're done looking at it. And then I would update this to our pickup logic. Now, if the target hasn't changed, then what I would do is current pickup target and on continue looking at. So otherwise, in any other scenario here, if we have a current pickup target, then I would go current pickup target on stop looking at, and I would clear it. So now the pickup has the information that it'll need for being able to potentially show a prompt. So we need to set up a bunch of functions here. Public void, and we'll allow these to be overridden on start looking at, public virtual void on stop looking at, and a public virtual void for continuing looking at. Because the idea is when we start looking at something, we want to show the prompt and we want to fade that in over time. So with our prompt, a header for the prompt, have a fade in time. We'll fade it in pretty rapidly. We'll have a fade out time. And we'll have a fade delay. So essentially, how long does it wait before it starts fading out? And we might make it that that's reasonably short. Half a second, I think, is as large as we would want to go with that. Because the idea is when we start looking at something, then, okay, we have different states here of we're starting to look at it, we're stopping looking at it, or we're continuing looking at it. So I'm just for now going to set up a state. So we'll have idle, starting to look at, looking at, stopping looking at. And what we would do is the state is going to start at idle. When we go to on start looking at, we would set the current state to that. I'm going to also need a time. So we'll have a transition progress, which what I will do in that case is transition progress is 0. Now the one exception that I might make to this, we could do some edge cases there for if you start looking back at something when, you already stopped, but I don't think there's no need for that. What I would then do is stop looking at, current state goes to stopping, transition progress goes to 0, and the on continue looking at, what we do with that is we would say, okay, the current state is just our looking at one. And for continue looking at, there's nothing we'll do just yet. So we've got these. We want to look at how we apply them, and there's not too much to it. What I would be doing is here in update, well, okay, if we are doing a state starting to look at, then the transition progress, well, that's going to be equal to, clamp it between 0 and 1, transition progress plus fade in time, and we use a time delta time divided by that. So that's going to advance the progress of that. We would be able to say with the canvas group here, we would go UI group alpha, is the transition progress. And what we would do is UI group game object set active to true. Now, if transition progress gets to above 1, we'd update the current state. So that's now looking at. Similar thing here for if the current state is stopping looking at. What I would do is, okay, we need to check if we've ahead of that cooldown or not. So we're going to need a float fade out cooldown. And we'll call that cooldown remaining. And what I will do is when we stop looking at something, we'll set the cooldown remaining to the fade delay. So the first check I would do here is, okay, if that is less than fade delay, so actually that would be if that's greater than or equal to 0, then fade out cooldown remaining, we subtract time delta time. Otherwise, if the fade out cooldown remaining is less than or equal to 0, then our transition progress, we update that similar to what we're doing here. We can actually use the exact same setup. But the difference is that rather than fade in time, this becomes fade out. And our UI groups alpha is 1 minus the transition progress, because the transition progress is going from 0 to 1. So we want to actually flip that so it does a fade out. And then finally I would check if the transition progress is greater than or equal to 1. Then what I do is UI group game object, we'll set that to false. And we set our current state to be idle. So this should mean that we have something where we can look at it and it should fade in. And if we look away, it should fade out. Now with the pickup scanner, what I'm going to do is the mask. Don't want it to look at VFX. It can check, don't want to ignore raycast, we want UI, and we don't want the player, so it won't collide against itself. So we've got our pickup here. Now this one is pickup on contact. I'm going to create another one. So this will be pickup contact, and this will be pickup prompt, which this will not be pickup on contact. And this one, rather than being a cube, I'm going to give this a sphere. Similar thing though, shrink its size a bunch. And much like how we offset the cube, I will also offset the sphere. And so we're just going to move this pickup. So that's our contact one. So the pickup prompt one, we're just going to move this over to here. So the pickup prompt one, what we're expecting to see is the cube, we go over towards it, nothing different. Should be exactly the same as before. We can wander over to that, no issue. Now the sphere, you can see we're getting close to it, but it's not picking anything up. So what we want to do is with our pickup scanner, check, because it should be doing a raycast. So we want to make sure that the raycast is actually finding something. A lot of stuff like this, it's very, very easy to run into. So it should be, and we can see that it picks it up. It successfully gets pickup logic. It's not a pickup on contact. It's matching, not matching the current one. So it's going to say start looking at. Current pickup target is still null. We update this. So it should mean that we've got the correct info in there. And so this is where we messed up, and it's going and setting it to null immediately afterwards. So what we need to do here is this actually needs to be found pickup is defaulting to false. We go found pickup is true. And then what we would say is if we didn't find a pickup, because then that goes down here. So if we didn't find anything, found pickup will stay as false. If we did look at something, that will be true, which will stop it from running the code here. So we can test that now. And what I'm expecting is I should then be able to wander over to this. I can look at it. Now I'm still not getting the prompt, so we want to just check and see what's happening. So we step through, seeing the same logic there. Found pickup has been set to true. It's doing on continue looking at. So we're not getting any stop events, which is good. And we just want to double check. So in this case, it is saying that it's no longer looking at it. Now, what is potentially happening is the mesh of that sphere, we didn't turn off its collision. So I'm going to turn its collision off because we shouldn't be getting stop events. Looking at it, and can just double check we're not getting any stop events, and we're not. It's continuing to look at it, so that's fixed that issue, which is good. Now that should mean that if we take a look at the update for the pickup, well, we're in the state looking at. So we're just going to put breakpoints in our starting and stopping looking at ones. So we're going to stop. That correctly picks that up, which is good. Fade out is updating, so that's good. So it's likely something then potentially in the starting looking at. So it's triggered for starting looking at it. We can see it has updated the progress, updated the alpha value there. Transition progress is not yet greater than 1. Has tried to set the game object, and it's tried to set the panel. And what it is going to be, so it's doing all of that correctly. We actually have a bit of a setup issue where the thing that we should be setting active should be the panel. So it's because it's setting just that panel game object to active. So what I would do in this case is there's a couple of options. Main one I think would be most appropriate is I would have a game object for the prompt canvas. And it's that prompt canvas that we will turn off and on is going to, I think, work better in this case. So we change set active, so it's running on that. Now the other thing that I will do is if this is not a pick up on contact one essentially. So if it's not pick up on contact, then we run this logic. Pick up on contact ones, I don't want it to run this logic for them. If we test that now, we should see our prompt appear and it should fade in, fade out, which is what we want. We've got it here. So look at it. So we didn't link up our prompt. So we make sure we link up our game object. And we'll link it up for both of them, just in case we ever want to support it for instant ones. So then now, wander over. and look at it. So it's putting up that prompt, which is good. So, okay, there's still room for improvement with that. So one thing I want to do is I'm going to actually shrink these a little bit. I'm going to actually halve the size of those. And I want them to look at the player. So that's the other thing, is I want these to be looking at the player while they are visible. So if UI group alpha is greater than 0, then we need it to face the player. So that's actually pretty easy to do. What I can generally do, there's a couple of ways of going about it, but one of the easiest ways is I can say, okay, well, our root object, which we have the transform for the UI root, we can actually try, just as a starting point, a look at, and what it looks at is camera.main and its transform position. So that is actually an option. So we can test that. Does that do the trick that we need? So what I want is, now I can see it's largely working, except we'll notice it's rotated. And we do get it appears very quickly, fade out time. We can probably reduce that fade out delay, I would say. So in both cases, that fade delay I'm going to halve. But we'll notice it's looking at it, but everything's flipped, which does happen. So there's a couple of ways we could go about addressing that. So one of the options that I could do is I could flip this location. Now it's a little bit messy. The other option that is actually a very viable one for doing this is our panel here. I can actually take those panels and set the rotation to 180. And with that, when I then take a look at this, what I should find is that now appears correctly. It's looking towards me, which is good. So it's always following. So one of the ways that could improve that is the prompts here. I want them to actually sort of, as I said, move with the object. So I could create an empty parent and change this to be called UI root. And we link that up actually as the UI root object. Now that empty parent, the position offsets, things like that we did here, I'm going to reposition the parent like that. And I'm going to offset the UI a little bit. I'm going to bring it forward about -0.5. Because if we then take a look, what this will do is it should just sort of orbit around the outside of the object. And we can see it does, not on the side that we want it to. So that's okay. We change this to be the other side of it. Probably reduce that a little bit to like 0.4, maybe even 0.25. Doesn't need to be too large an amount. And now that's going to appear a bit in front of it. Could probably then go and increase that to more like 0.35, and we make sure it's actually off by default. And now we go and look at this. Always appears in front of it. And okay, still can't pick it up yet, so we need to detect the prompt. We're going to reconfigure this one so it's got the same sort of setup, just so that we've got the option if we ever do want to have our instant ones actually displaying a message as well. It means that we just have the option there for it, and it's good to make sure we've got that option. We'll also set the descriptions here. instant pickup, and we'll call this one press to pick up. So we need to actually detect that we've tried to press. So with our input, we can take a look and see what are our input actions set up. So we don't have a use interaction currently set up. We do have primary interaction, but that's not really, that would be sort of more used for things like fire, stuff like that. So what I would do is I would actually set up something where I'm going to create a copy of this. I'm going to call this pickup. And in terms of what buttons we use, so we already have button south and east used. I'm going to change this so that it uses button north on the gamepad. There will not be a mouse control. Touch, we're going to omit for the moment. Joystick will omit. We'll just focus on the gamepad and the keyboard, which for the keyboard, similar to what we've got for things like jump and stuff like that, I'm going to add in a binding, and this will just correspond to E. So we can save that asset. So that means on pickup is now something that can be registered. And with the stuff using the send message setup, if we go to the player character motor, the same approach here that we use for stuff like jump, we can actually use that for our pickup. So this would sit on the pickup scanner. So this would have on pickup. And what we would do is if value is pressed, and we have a current pickup. So, and current pickup target, and we would go current pickup target, perform pickup. We would also need to check that it can be picked up. We don't have a circumstance where it can't be at the moment, but good to just check. We also need to make sure then scanner here brings in the input system. So that should mean that as long as that prompt is visible, that we can pick this up. So we're going to check that. We wander over, it's visible, and we can pick it up. So that's great. We've got our setups there for the pickup. I am going to change so that the prompt happens for anything that just has a particular prompt. So I'm going to set up a field, serialized field, public bool, has pickup prompt. So that these will check if it has a pickup prompt. And then in the pickup scanner, it'll only send those events for if it has a pickup prompt. So that way, anything can get those events. It does mean we change down here. Has to not be a pickup on contact, just so we can't inadvertently go and pick ones up. So this will allow us to give this one a prompt. This one also has a prompt. So they can both show up a message, but only one of them will actually react when I press E. So this one will react, this one won't. Now it is having its UI appear not in the right location, so we do just want to go and make sure we fix that up. So both of those have got the right settings. Panel, everything like that is correct, but what we didn't adjust is the UI root that the contact one is linking to. So that needs to link to that. So we'll have our two prefabs then, or two things that we can then prefab. So that's good. Instant pickup. So now with that, we don't want to show that E message. So what I would do is in our pickup, F has pickup prompt and it is not pickup on contact, then I'm going to hide the instruction text. So instruction text enabled, and actually what I could do is just its game object, we set that off. The other thing I could do is it only gets set to true if it has a pickup prompt and it's pickup on contact, and then I could use that without even doing a conditional. So what that will mean is we don't then have stuff appearing there that is confusing or misleading for the player, which is what we want to avoid. We don't want anything there that's going to be confusing. Now that one, so we've actually got it flipped. It has pickup prompt and it is not pickup on contact. So we had them inverted, easily happened. Should now have our two setups where we've got one that I can run over that and nothing happens. Look at it, shows the prompt. Look at this other one, need to be closer to see it. We've got our two ones, that's good. This one, pressing E does nothing. This one picks it up, whereas in this one, I run over it and it collects it. So now we've got a generic pickup system. Those pickups will send out an event saying that they have been picked up. So these are all that's left is to actually turn these into prefabs. And what I will do is we'll have a pickup on contact and a pickup on use. So it's just useful to have these as separate base prefabs, and what we would change in each one is we'd update the description, we would update the mesh that gets shown. So it gives us a set of ones we can easily just scatter around the level that we can then pick up and that we can pick up in a generic setup. So dive in and experiment with this, see what kinds of bits you might want to add to it, other pickups, things like if that you might want to add and support there, if there's additional things you might want to be adding in for your own projects. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, really helps out, it's really appreciated. If you've got any questions, chuck in a comment below. If you're looking for the code for the project, the code is available up on GitHub. There's a link to that in the description, and you can use this code in any of your own projects, commercial or non-commercial ones. You're able to be making use of it there. And if you are looking to search for other related videos, there's also a link in the description to the video archive, which is a searchable archive of all of the videos that have been released. And finally, if you're looking for other ways to support the channel, I do have a Patreon, and there's a link to that in the description below. But until next time, bye.